Alright students, so next we got some good thorough challenge problems, but I really like these challenge problems. We're really going to push ourselves. So the first one is triangle XYZ is shown. Which triangle must be similar to triangle XYZ? So let's look at A. We're just going to draw each example and see which of these examples is similar to this triangle over here. Alright, so triangle with angle measures 40 degrees and 60 degrees. Well, I'm just going to draw, well, let me do my best. If I have a triangle of 40 degrees and 60 degrees, well, this last angle must be 80 degrees. All right, well, remember, I have the angle similarity postulate. I'm going to just write A up here. I need two angles that are congruent, which forces the third one to be congruent. Well, over here, well, this also has to be 40 degrees. So I don't have three angles, or two angles. I don't even have two angles, so A doesn't work. Two angles aren't congruent to the one I have, so A, bad. Well, let me try B, a scalene triangle with only one measure 40 degrees, or excuse me, 100 degrees. So this seems promising. It's scalene, and I have a 100-degree angle. Well, what are the rest of these angles? Well, I'm not sure in B what the rest of the angles are, but over here, the triangle I have, it has to be isosceles. All right, and remember, when you have a scalene triangle, none of the angles are the same, so can't equal 40 degrees. Same thing over here. They can't equal 40 degrees because if one of them equals 40 degrees, then both has to equal 40 degrees. So B is bad. That doesn't work either. An isosceles triangle with only one angle measure 40 degrees. So we have an isosceles triangle. We already know the one we have is isosceles. But we have to read it carefully. This only has one angle that's 40 degrees. And since it's isosceles, the rest have to be, let me think, I think 70 degrees. So again, we don't have two angles that are congruent. So C's bad, and it turns out green's the good one. Why? A triangle with two angle measures that are 40 degrees. Well, I'm going to draw this over here, and it's really just going to force everything to be this. It gives us angle immediately. All right, I have 40 degrees, 40 degrees. All right, angle works. And in fact, this last one has to be 100 degrees, and then the sides are proportional, so on and so forth. So yay. All right. And this one right here, James correctly proves the similarity of triangles DAC and DBA are as shown. All right, so this is very, very lengthy. All right, so I stole this from the air test, and that's why I want to talk about it. So it's basically saying CAB and ADB are right angles. So CAB and ADB are right angles. Saying that the measure of ADB and ADC are 180 degrees, so then that's going to force this to be a right angle. So right now, basically we can go so on and so forth and say, well, let's focus on three triangles. We got this triangle right here. It's a right triangle. We got this triangle right here. The right triangle, and lastly we got this triangle right here, and this also is a right triangle. So we got three triangles that are a right triangle. Furthermore, just kind of cruising along looking at this proof, so let me think about this. All right, so ultimately we're not even going to look at the proof, we're just going to look at what we know. Notice how the green triangle, I'm going to write green triangle and pink triangle. They both have a right angle, and they both have angle C. So you have a 90-degree angle. 90-degree angles are congruent, and angle C. So they are congruent by angle. They both are a right triangle with angle C, so they have two angles that are congruent. This green triangle, so that was pink, and this purple triangle, they both have a right angle and angle B. All right, this green triangle is a right angle, and they both have the right, or angle B right there. So again, those are congruent by angle, angle. So basically, this whole 2-column proof just goes through, well, they have 90-degree angles, right angles are congruent, reflexive properties. So how do we know these are congruent? This is by the angle-angle postulate, and that's really what this is looking at. And why I wanted to look at this error test problem, very lengthy, very dense, but just break it down into what you know, what we've been talking about, and we can figure it out from there.